So, and this kind of shows you another little overview of kind of what's going on. The this router D, it's got the similar configuration of what we were just putting on the other one. First of all, again, notice the OSPF process ID numbers on these two routers. They do not match. They don't have to match. So router D is completely in area 0 over here. All the networks it's advertising are going to be labeled as area 0. But router B over here is an ABR, area border router. So it's got to have networks in 2 different areas. So on the area 51 side, it's got the 192.168.1.8/30. That's labeled as area 51. Now you don't have to put this 172.17 network on the configuration of this router because it's not directly connected to it. You're going to have that advertised by router C, so you don't have to worry about. You only have to worry about advertising the networks that are directly connected to that router. So additional OSPF commands gets into like the little a lot of different stuff you can tweak depending on your network and what you're trying to do. To configure an area as a stub, use this on all routers in that area. It's just from router configuration mode, area, space, area number, and then stub. We're going to talk about stub networks in a bit. To summarize a group of networks, in this case 192.168.4.0/24 through 192.168.7.0/24, use the range command. And actually I need to correct this line. This the 4 and the 1 should actually be swapped right here, so that the command should be area space 50 space range 192.168.4.0 actually to get the full network, and then the subnet mask is 255.255.252.0, and that 252 right there, starting with the .4 actually makes it where it goes .4, .5, .6, and .7. So you end up grabbing all of these rather than having to advertise each of the individual 4 routes that you would have to show. If you want a router to advertise its default route to OSPF, it's from router configuration mode, default information space originate. And then to manipulate the OSPF cost on an interface, we talked about this before. When you get to gigabit Ethernet interfaces, it's always going to assume the value is 1 if you want to change that value. In this case, they're changing it on a serial interface. I guess there may be a particular reason you want it to prefer a serial interface over another interface. It's from interface configuration mode, interface space and then your interface name and number. From interface configuration mode, IP space OSPF space cost, and then the new cost value you want to set there, in this case 3. To change the priority of a router to be preferred is the DR/BDR. This is an important one. You may very well have simulations on your, definitely questions, possibly simulations on your exam, where you're going to have to change the DR/BDR. It's interface space, whatever your interface name and number is, and then from interface configuration mode, IP space OSPF space priority, and then the value. Remember, 0 takes it out of the DR/BDR election process altogether. The value of 1 is what they're always going to be set to unless you change it, and higher values are preferred. So if you want this to be the DR/BDR, in this case we're setting it to 4, we might set the BDR value to 3. And then for verifying and troubleshooting OSPF, show IP route command is extremely important all through networking. Either show IP route just to show your whole routing table, or show IP route and then an IP address to see where that particular IP goes to. Show IP OSPF neighbor, and you can also do show IP OSPF neighbor and an IP address if you're looking at a specific neighbor. The state you want to see those in is full. That means everything is meshed up together. All the tables have been exchanged. The neighborship is there. You can also use the show IP OSPF database summary and the show IP OSPF interface commands. And then if you really get into the nitty-gritty and you're having some trouble, you can debug OSPF with the debug IP OSPF events command. And again, I say this on every command I show you guys that has a debug. You only want to use that debug while you're actually looking at it. Don't leave debugs running because they take up a lot of router resources. Make sure you do the undebug all command whenever you're done debugging for anything. And I'm actually going to cut the video right there because we're going to jump into